And we're good. Okay, so today, server-side template injections. As I said before, should have probably kept it for next term, but anyways, we'll recap on that. So let's get straight into it. Today's quote from Thomas Edison. Just because something doesn't do what you planned it to do doesn't mean it's useless, which is quite nice regarding templates, because sometimes you want a template to do something, but even if it doesn't do it, it might do something else as useful. So, lecture content for today, changing a bit the structure of what I do as lecture notes, getting inspired by what Adam does, because I really like his lecture slides, so trying to add a bit more color so you guys don't fall asleep. This is the content for today. So let's start by the basics before we start seeing what are server-side template injections. What are templating engines first? The thing that work with the templates. So templating engines, it's similar to what we saw last week with SQL and SQL having its dialects. Templates have their dialects as well, which are called templating engines. These tools, they help you generate the HTML page with some predefined, for example, double quotation marks, or what we call the one with the wave. For a dictionary, what is it called in English? The curly wave, curly bracket, perfect, exactly. So some templating engines and use curly brackets, some other would use a hashtag, other things to define what should be replaced in the template by your variable. So, have you used Flask in your life? Django, templating engine, Jinja, you probably already heard of it. It's very, very useful. So today I'm going to do a few demonstrations, one with Twig, one with Jinja, and I think I'll cover Smarties quite quick, but not a lot. So why is it as important, and why do I want to talk about this? It's because the content of what you render when you use a template is rendered on the server side. What does that change? You're going to ask me, and I'm going to tell you everything. You know, when you have an XSS, cross-site scripting, affects only the client side. What are you going to do with this, okay? I'm going to send the malicious link to my friend. He's going to click on it. I'm going to steal his cookies. Woo! Not very exciting. But with template, when you do server-side template injection with the keyword server-side, meaning that everything that you execute is executed on the server. And maybe the server has access to stuff that you shouldn't be able to see as a user. Maybe local for the enterprise local API endpoints that only the server can hit. Maybe other things like that would make it way more dangerous than something only contained on the client. So that's templating engines for you. So a quick life cycle of a templating engine, would be, firstly, you load an HTML template that you made or that you just picked up online for your templating engine. Then you insert your dynamic values in your templating engine. So for example, if I want my webpage to say, hello, Maxim, because my name as a user is Maxim, then my dynamic values will be Maxim, and they're integrated in my template, which already had the hello input, something. So this is the second step. Then, once this is done, everything is matched, we execute. The logic, because you can have loops, you can have conditions, and you can have everything in a template, which makes it very useful, but very dangerous. For us, perfect. So then, once the template, so you loaded it, you inserted the dynamic values, you executed everything that was inside, then you have a fully formatted HTML page that is dynamically rendered with, for example, the username, the date of birth, the genre, and everything dynamically made for these values to display. The user never sees the template, only the final generated HTML page. All clear? Perfect. So, why use templating engine? And you're going to ask me, what the hell is this picture? And I'm going to tell you, this is a picture of the templates on Canva. Why did I pick that here? Because it works more or less exactly the same way. On Canva, you have different people that release different templates that you can use for your own projects with tiny modifications. And that's perfect. That's it done for you. When using a templating engine, you can do that. So you can take templates that have already been made by people, but you can also make your own template from zero and share it to other people, which makes it, again, very powerful, but very dangerous. Because, okay, I don't like you. I'm going to make a template, which is bad, and I'm going to share it to you saying, wow, lovely template. And you're going to download it and think, wow, lovely template. But at the end of the day, I'm going to get your cookies. And I'm going to be the one thinking, wow, lovely template. So be careful when downloading pre-made templates. And while making templates, you can make mistakes. And always verify that it's not executable. So you can reuse them. That's the base of templating. Create dynamic content base as well. Reuse them. Safe variable insertion. You can see the big parentheses. Yes.
Surely in the scenario the templates are open source, you can just check malicious code in them.
For official templates, yes. When you have, for example, Jinja or really the developers that release their own templates, they will be open source GitHub repos, like 4,000 stars or 50,000 stars. You'll see really that it's been seen and reread, everything like broke the thing down to the bits, to a single bit. So there won't be any problems on open source stuff, but you never know. That's why I would always recommend checking. When it's from validated developers, of course, less rigorous checking, but when it's from random stuff, maybe you're looking for a template that does specifically something, and a guy online did specifically this template, no one else did, but he's not a very known developer. In that case, I would recommend always checking what you're putting in your template. You're going to tell me, but what can he do? Absolutely nothing if he doesn't find my webpage and input stuff on his broken template. True. But at the end of the day, we should always check what we download and what we use for it to be secure. That's the end reason, most of it. So templates, when used properly, faster, cleaner, more organized. You get the idea. Okay, quick example of how a templating engine and how a template will be made and what it will render at the end of the day. So, start here. This is a template from Jinja, which is the Python templating engine used on Flask and Django, for example. Here you have a basic HTML document, and you can see you have the curly brackets. So I'm going to talk about different curly brackets. Let's talk about the title curly brackets first. So here, this snippet of HTML template maps with this snippet of dynamic templating code. Can you see something that could be an issue for the title using these two snippets of code? Normally, what would the title show on the final rendered HTML page if I just use it like this? Anyone has a guess? There are no wrong answers. Quick guess. So I know what's bothering you. You're seeing a pipe escape. What the hell is pipe? Oh yeah, go for it.
While you're escaping it, does that mean that it's like formatted as HTML, or it's not formatted as HTML?
You got it. Yeah. It's not formatted as HTML. So you see here the initial variable. It's a variable, but you can see there is an HTML tag called unsafe. So if you use it here, and the pipe in Jinja is a filter, if you use it here and you filter your variable and escape the HTML characters, then this tag will not be rendered and will be escaped properly. But if you forget your escape, then it will be rendered exactly like it is here. Next question, you see the curly brackets here again, and you see there's a for loop. How they spawn here, a condition, and then there's something, item, why does it have two curly brackets, why only one, why is there n% at the start, not n%, percentages, and your curly percentages, why not double curly brackets? What do you think would be item here in this script? So as you can see, there's a loop on something, for item in item list, nice. Item list being defined here, so we can think it's just going to iterate. And if not loop dot last, then end if. What do you think is going to be printed here? Ooh. And just forget. Any ideas? Simply the loop. I don't know why I was keeping you guys so long for that, but simply the loop at the end without the comma for the last number. So this is what will be rendered with the data that we just gave it before. And as you can see, the most important part here is the escaped variable. And as you rightfully said, it is escaped from HTML, making it absolutely unharmful. Okay, so big problem. We have a lot of templating frameworks. We have, when I say a lot, I mean a lot of templating frameworks. So how to know when something is going to work on a template but not on others? Good question. This question will be answered because to test for server-side template injection, there are specific variations of each testing payload for a specific templating framework. It might seem very, very confusing right now, but you'll see Makes perfect sense once you really do it. So, templating frameworks most of the time work with specific programming language. So the most common one, the one you're going to see all of the time in CTFs, Jinja, because it works on Flask and Django. Mako as well, quite useful. JavaScript, EGS, Handlebar, Mustache, I don't know if you've already heard of them. PHP, Twig, very popular. Smarty, very popular as well. And Ruby, you have a few of them as well here. And of course, you have a few in Java and Node.js. This list is, as I say every time, non-exhaustive. There are more than that, but these are the more common one. And yeah, that's it. Why is there a big pug in the middle of the screen, you might ask? Because Jade was previously called, Pug was previously called Jade and is now Pug. So the icon of a pug is Pug. You could have guessed it. Okay, so now you have the context. You know what is a template. You know what is templating engine or templating framework. How can we break that and how can we make it work? So first thing you need to have to have a server-side template injection is user input. You need to be able to input some malicious data somewhere. It's always the same game in cybersecurity. Never trust user input. If you trust user input, good luck. Really good luck. But here, if you trust user input, then you give them a possibility to insert some malicious statement. So malicious statements for server-side template injections will most likely look something like that. So curly bracket, 7 times 7, or 7 times string 7, or hashtag curly bracket 7 times 7. Most of the time it will be with the numbers 7 times 7. Why? Because if this is interpreted correctly, it will not return 7 times 7 in the brackets. It will return 49 because it will be calculated by the server. And that's how we can check. If you input something like that and it returns you the number 49 here, and if you get that, that means that your statement was executed on the server, and that's where the real magic starts, and when you start having real fun trying to find exactly what payload will make your thing work. But that means it's vulnerable to server-side template injection. So with server-side template injection, you can do anything you want. Remote code execution, file access, data exposure, anything you want if you have access to the server. And if by luck you're root, when you do that, sorted, you have everything you want. Yes, go for it.
So instead of 7 times 7, could I do like any calculation, like 2 plus 1?
Anything.
3, then I know.
Yeah, anything. 7 times 7 is very used because I don't know historically why it's 7 times 7. But most of the time, maybe I have an example that I can show. Yeah, as you can see here, you see all these examples are most of the time done with 7 times 7, but you can do it with anything. And in certain testing payloads, it's not numbers. It's putting something in uppercase or in lowercase. And yeah, in this case, there's no numbers, but it's a good question. No, you can do it any number, as long as it's interpretable math for the templating engine. So again, because it's on the server, it makes it really, really dangerous. Because if it was only on a client being yourself, what are you going to do? Send the vulnerable link to your friend and, okay, have fun because he clicked on the vulnerable link and you grab this cookie. Okay, in this case, you can really shut the site down, shut everything down, get access to the original machine that was running the site, get access to everything, so it's really dangerous. Quick definition by Portswinger. On this one, I thought they had the best definition. Server-side template injection is when an attacker is able to use native template syntax to inject a malicious payload into a template, which is then executed server-side. When does that happen? User input. When you trust user-controlled data, I'm not going to say enough this year. Never trust your user data because you only need one to break your whole application. So lack of proper escaping sanitation, this can be good, but don't rely only on that because you can bypass it. Dangerous functions, they're in any programming language, so be careful and learn what functions are usable or not. Template engine can execute expressions, so that's what makes everything dangerous. And we can use the logic to make something very nice. Are they dangerous? And here I really wanted to add the server part so you guys can really understand why it's as dangerous as it is and why it's really fun to do because it's not as hard. I'm coming to that in 1 second. So RCE, anything you want. I'm not going to read through that. You get the idea. You can really do whatever you want. Why did I choose this meme? Because it's for phishing attacks, but it works for templates as well. You can fall for templates, server-side template injections if you don't use templates. So of course, if you want to make your life more complicated, you can. You'll not be vulnerable to template server-side template injections, but you won't have any templates. So sad times. But if ever, as an attacker, I'm able to gain access and find this vulnerability, I can do anything. Internal APIs, hit your internal company APIs. I can try to figure out your whole backend logic and work with your templates, see if I cannot inject somewhere else, having more access to your file system, to your environment variables, API keys, token, passwords. Even sometimes if I'm logged in as root, as said before, on the server, I have everything. So, very, very dangerous. Methodology. Let's go into the fun stuff. So, firstly, what you want to do, you want to detect, identify, and exploit. This is for server-side template injection, the methodology. You have the CIA triad here. Detect, identify, exploit. So, detect, you fuzz. You can try fuzzing using the things that are used in the templates most of the time. Try to see if you have an error, something that can maybe give you a bit of an insight of what's going on. And then try with the harmless payloads. Right now, we're not focusing on specific template payloads yet. We're just testing their general payloads, seeing if we can grab a response, maybe see if we're vulnerable or not. This is the first stage. Can we exploit or can we not exploit? Is there a possibility to look further into or not? So detection. Then, to give a bit more context, for server-side template injections, we have two possibilities. We have the plain text context possibility and we have the code context possibility. In our case, the plain text context, as you can probably guess, is I input 7 times 7, it gives me back 7 times 7, does not execute, is interpreted as plain text. We don't care. We don't want that. If that is the case, goodbye server-side template injection. It's not happening. But, and this is more likely for XSS than SSTI, but I'll come to the relation between both in an instant. What we want is a code context where we have an evaluation of what we input. Here, 7 times 7 does 49. We have sometimes errors that give us a bit of background, and what we want, the loot, is the RCE. That's really what we want. So now we've detected possibility to have a server-side template injection. Let's go a bit more in depth, see if we can identify the templating engine so we can really start making our payload. So to identify, you will start submitting invalid syntax related to possible templates that you want to do. So that's where we start getting really specific in that you have to do your research. Manually, you will test different language, but also you can do it with automatic tools. I will never recommend to do it first. Just do it automatically. Just do it manually first. And they have a very similar syntax, so don't get confused. Even if it's not the same thing, having a similar syntax will make you'll have the kind of moments where you'll think, oh, but is it not what I've just done previously? Or no? Oh, no, because there's going to be a comma that's going to do everything different. So similar, but not the same. Okay, quick roadmap. Most of the time, you always start by a dollar, comma, I forgot the name again. Spicy comma, I don't know what this, curly brackets, thank you. Yeah, so dollar curly brackets, 7 times 7 or mathematical expression. Red arrow meaning no outputs, green arrow meaning what we intended. And here, most of the time, if this doesn't render, you would go straight for this one, as the roadmap says for now. And this is where I want you guys to see the difference between this one and this one. Between the 7 times 7 and the 7 times bracket 7. So, as you can see, at the end of the day, if this doesn't work, it's considered non-vulnerable. If this works, then it can be one of two, Jinja or Twig. Then, depending on the result that you get, you can identify if it's Jinja or Twig. You can probably think that in programmation, when you do 7 times a string, you will get this string 7 times, which is what happens when you do the execution in Python. So in Jinja 2, you will get 7 times. But if you're in PHP, this will be 49. So 7 times string 7 will still evaluate to 49 in Twig. Twig is PHP, so that's it. So that's a small roadmap to see that, you start somewhere, then you go a bit further, maybe you get no results, you come back, and that's how you identify your templating engine based on specific syntax changes that you can see here. So this is a Portswinger roadmap, by the way. I did not do this roadmap, so if you want to see the Portswinger article on server-side template injection is magnificent, so I would only suggest going to take a look at that. Okay, we've identified. We've detected, we've identified. Now, time to exploit. So, we start. What do we want? we'll every time recon first. What do we want? What are we looking for? Are we looking for the RCE? Are we looking for a simple flag file? Are we looking for whole access? Maybe we want to pivot to another system, something else. This will drastically change the way you make your payload. So you need to know what is your objective. Then start doing your research. Okay, what is the templating structure? What programming language is it using? Can I use this payload to do something? Maybe this, maybe something else. Really narrow down your scope and really learn your target. Then identify, is there filters, is there firewalls? Can I bypass these filters by using URL encoding, double URL encoding, things like that? Is there firewalls I can bypass as well? If all these 3 points have been cleared, no filter or I bypass this filter, research has been done, initial recon has been done, then you can start developing your payload. So then you'll have to go back to your research step, learn how you can change specific stuff, because you can guess when I say develop your payload, it's not going to be SSH root or something like that, or spawn shell root or something like that. It will be a chain of specific programs calling specific things, and at the end of the day, you can input your command, which will be returned on your HTML page, which is absolutely wonderful. But your payload is not going to be something simple, it'll probably be chained of something plus something plus something plus something. It's just, you just need to find that out. So once you have that, can you exfiltrate on your HTML page directly? Most of the time you will be able. If not, you can try to do some stuff with out-of-band exfiltration like we saw in SQL injection. Maybe exfiltrate via an HTML request, a parameter, something like that, if not doable directly. And there comes the XSS that I talked about. Server-side template injections occur on the server, but the final render template is sent to the browser, so also checked for XSS, because you can have XSS caused by server-side template injections. So imagine I put my... Please, here? Yeah, imagine I put my curly brackets like this. I'm in a code context, and my 7.7 is interpreted to 49. What can I do then? If it's... And I know it's executed. What can I start to do? Instead of doing mathematics, and in XSS context, if I know this is executed,
Get data?
you can get data, and you can also start using script tags or using tags in these injections that you put here to have your code executed on the templates. And because initially when it's going to make the template, it's just going to make the code. But when you reach the execution step, then your logic will be compiled, and then you will have all your XSS directly on your browser without doing it, with your initial, just in the input. You will have to curly brackets, then use your script tag, your alert, something. As we saw here, it will initially be loaded as a dynamic value, just a simple string. Then it will be executed as logic. And when it outputs the fully formatted thing, it will just be a script tag, and then it will execute your XSS. So be careful. Server-side template injections and cross-site scripting are very closely related, not to be confused. Cross-site scripting is client-side, server-side template injection is server-side. First question for you guys. So, here, imagine I have this page. It's taken from Try Hack Me, so people have probably already done this lab, but still give it a go. Imagine I have this page. I'm trying to guess what is the templating engine, and I just know that when I inputted this is vulnerable to server-side template injection. I inputted this, I got this answer. Based on what I said before, could you tell me what the templating engine is? Here.
Jinja.
Exactly, Jinja. So here, Jinja, because as we said before, this structure that evaluates is only viable for two options, Twig or Jinja. If it's Twig, it'll evaluate to 49, because here I hope you also saw that the second 7 was a string. So we are really in our example that we saw before. 7 times a string is going to show this string 7 times in Python. So that's the case here for Jinja. But for PHP, it will be evaluated to 49 because it would not consider the second 7 being a string and would just do it mathematically. A bit more complicated now. If I do this, and I have this in Twig, I just said it before, maybe I should have talked less. What is the programming language used by Twig? This, if you listen just a bit before, you should know.
PHP?
Yeah, exactly. Yes, the man raised his hand like there, but you're right. Now just go for it. So yeah, this is PHP, but you can see this is most of the time how it would look. You would have user input that you would manipulate, and then you would have an evaluation of the results, which would be what you do. So, quick example. This, I wish I had my laser pointer, but I do not. So here, this is the vulnerable code initially made by some guy that developed it, that didn't know about cybersecurity. He made something which dynamically renders the name of the user after a hello, and yeah, it renders the templates in Python in Jinja. Okay, until here, not much to say. Then I take a look at this templates on HTML, and I see that it is vulnerable to server-side template injection. And evaluating to 49 on this payload, can you tell me if there's a difference between the other one and this one? Because if it's Jinja, I don't know if you remember, but the payload just before on Jinja was evaluated to 7 times 7. Why is this one evaluated to 49? Exactly, yeah, I don't know how you see that well from back there, but congrats. So yeah, this exactly, because the second 7 is not a string. So it's just evaluating it mathematically normally. That's also a case of Python. So when I say the templating frameworks are very similar but different, this is where you can really mess up. If you forget only something, you can think that you're using a template when you're using actually a very different one. So here we know it's Jinja. And so you're going to ask me, what the hell is that? And I'm going to tell you, this is something you use to make your final payload, which works. So here, I'm going to talk a bit more about this on the next slide. But here, what you need to understand is this is only viable for Jinja, and this is not applicable for everyone. But here you have a global class in Python, so you have to know that this is sandbox. This is really, they try to block it off as much as possible from importing specific libraries or doing specific things for us not to be able to break out. But you can use, I don't know how really call it. It's not a God class, but it is quite. Yeah, it is the God class. You can see what is downloaded for the templating engine, and some libraries, some classes that are pre-downloaded can be used to open a terminal or access the file system. Specifically, one called popen. Popen is a typical library that you would use to really get your ls commands or maybe spawn a shell or anything like that. So here, what I'm doing with this first just tiny thing that you can see here, just before the 157, is looking in the classes and trying to see if I have my popen. So you see, it's not just something. It's just not just, oh, okay, SSTI, I just drop open shell and that's it, I got my shell. No, you have to identify what class you're going to be able to use to spawn your ls command, then if you're going to be able to get your outputs, or you're going to be able to change your commands, anything like that. So here, check my classes, then I identified 157. As you can probably guess, the index of 157 here is popen. But you can do it on other ways. But here I'm just saying, okay, in my God class, I use popen. And I use popen built-in methods, import this, and use some process that you know. And then I can use something called check output of ls command to see and to execute commands directly. Does this make sense? Sort of. What could be clearer? This is, you have to know that this is only viable for Python, and PHP, or different programming language or templating engines will have sometimes much simpler things to do, or sometimes much longer things to do. But for Python, this is most of the time the way to open and to spawn something is using the classes of the templating engine directly. I mean, you probably think that you could use something as import OS and then support something because it's Python. But no, the templating engines really block the use of the normal Python methods, so you have to use the templating methods directly. Okay, so lot of text, lot of weird stuff. I'm going to go really clearly through it. So this is, to come back to the example I just showed before, we are still in Jinja. We are still in Python. And this is exactly the same payload as here. I mean, for details, but it's supposed to do exactly the same thing. As you can see, the first 2 lines are 2 different methods of doing exactly the same thing, as long as you replace a big file name by app flag txt. But this is exactly the same thing. As you can see, there's very different methods to do it. And why am I showing you that right now? It's because First line, you can see I'm using the 157 here as an index to find p open. But what happens if, there's no way for me to know that it's in index 157, or I just don't want to be bothered? Then I do the second payload here that you can see. I'm not using any index, but I'm checking if my class name is p open, then I use it. You can do it this way as well, which makes it work, and which for me is the preferred version, because I don't want to go through the probably 200 classes and see, oh, p open is 157, and I have to rewrite on my thing. So I'm just going to do something like that. As you can see, single curly bracket for conditions, but double curly brackets for actual statements. So here, single curly brackets for the ifs, for the fors, and for the end ifs and m-fors, but for double curly brackets for the real actual parts that is executed if the conditions are met. Here, this one, so not the last one, just this one. Same thing, exactly the same as the first two lines, the first two payloads, but you're gonna ask me, why did I put 3 times the same payload? And I'm gonna tell you what happens if your filter blocks the double curly brackets. How are you gonna bypass that? If your filter blocks the double curly brackets, which happens a lot in challenges, how am I gonna bypass it? With the third payload. First one, double curly brackets, won't bypass the filter. Second one, double curly brackets, only for the statement, not for the conditions, still won't bypass the filter. Third one, no double curly brackets. How come? Because in Jinja, if you set a variable, and you don't need to set up the 2 curly brackets, even if it's within conditions. So this very, very, very useful filter bypass for Jinja if the filter blocks double curly brackets. And the quick explanation of what I just said before, MRO is the base object, not the God class, but the base object class. And here you open the subclasses, and 157 is the popen class most of the time. Here you can also use the second method where you just check the name, and then you dynamically import it and use subprocess to execute the ls command. You get the idea. But do you guys understand for Jinja, I repeat again, this is only for Jinja, how most of the time we can structure a payload, stuff like that? Yep, okay, all good? Okay. Quick other example, because I didn't want to talk only about Jinja on this hour, I really want to show you the difference. Here, for Pug, or Jade, this, if I'm not mistaken, is Node.js? Yeah, it's Node.js, yes, okay, sorry, I get confused every time. Yeah, this one is Node.js. Why did I put this example? It's to show you that it's just very, very different things. From Python, where you had to change all the different stuff with the underscores and the whole big long commands. In Node.js, very simple. As you can see here, we don't have the double curly brackets. We have a hashtag curly brackets. So you have different statements that may enable you to talk to the templating engine, because it's not the same templating engine, different stuff. Here, root process, main module, require, child process, same for the 3 lines. Then the 3 things you can just see that I'm just executing 3 different commands. And really think about the sponsing syntax, where you input a string and then you put a comma and you have a list of all the arguments that you want to input when you have something like that. Be careful to the syntax, it can get a lot of people lost. Here, root process, okay, global process from Node.js with the Plutter template. Main module, okay, yeah, you get the idea. Same thing, I'm executing commands, but I'm using something different to make it happen. Okay, how do I prevent it now? So, best way to prevent, surprising, don't allow any user inputs, or don't allow the user input to modify and submit the new template. You're gonna think I really hate users by the end of the year, but you need to secure anything that comes from a user you need to escape everything, you need to really check, because you just need one user that want to break your site, and if you didn't handle everything, he's gonna succeed very, very much. So logic-less templates such as Mustache that I didn't know before making this lecture. So something called logic templates is stuff like Django, not Django, so stuff like Jinja, Smarties, Twig, you get the idea. But logic-less templates really isolates the whole code parts and makes you less vulnerable to server-side template injection. Okay, only execute users' code in sandbox environments, but as we saw here, even in sandbox, we can break out. And finally, accept that RCE, so arbitrary code execution, remote code execution, is the only, it will happen. It's inevitable, but you can apply your own sandboxing by deploying template environments in a lockdown Docker container, for example. Good luck. I wouldn't suggest following the last bullet point, but you can do whatever you want. If you really want to control everything, then you can make your own sandboxing. I would never recommend making your own sandboxing except if you know exactly what you're doing from zero, but feel free to try it out. So, quick recap. As the start of the lecture, I said that I included a 10-minute video in this lecture to change a bit of the usual format. Should I? No, not this time. Yeah, I think it's better if the last lecture before Christmas. I'm not gonna keep you guys until 25. So yeah, I would only recommend if you guys are interested in server-side template injections or you have future CTFs that you want to do to take a look at this video. It's absolutely wonderful. This schema that you have here is also from the video and explains very well. And this guy does a lot of things on cross-site scripting, SQL injections. You get the idea. He's a very good YouTuber for cybersecurity. So go for it. And last thing I wanted to add before I let you guys go were tools for SSTI and detection and exploitation. So usual tools, Burp Suite, template fuzzing word list. So there's a repo on GitHub called Payload All the Things. You will find everything that you want. Really everything that you want, because Payload All the Things is greatest thing on earth. Of course, you have custom server-side scripting payloads. A Nuclei template, I will suggest you go take a look at Nuclei. It's a good vulnerability scanner. A Wapalizer, very good Wapalizer. I might have it installed here to tell you what website is running as technologies and things like that. And tools to exploit. There are payload cheat sheets for every templating engine that you can find online. And the GOAT, TPL map, one of the only automated server-side template in injection exploitation tools. One of the only. The most famous one by far. Of course, you can make your custom scripts. You can use Burp Suite Repeater and CyberChef that I can only recommend to decode and encode payloads when you need to bypass filters. That's it. So that's it for today. Hopefully you guys understood everything. I am gonna skip over this video for today, but feel free to watch it at home. I can only recommend it for Christmas, 25, you're happy, Christmas, server-side template injection video. That's the perfect moment. So yeah, thank you very much. I really wanted to say thank you for this start of the year. For showing up, guys, and hopefully we can do even better in term 2. There are a few things that we have planned that are coming in term 2. Merch, finally, because better late than never. And so we're getting that validated right now. We're going to continue on the lectures, change a few things, and finally probably going to release actual timetable instead of every week. We don't really know what's going to be next week, I'm going to try to work on an actual timetable and get, so you guys can really see what you want to attend and what interests you more than other things. And if you have any suggestions, WhatsApp, Instagram, wherever, you know where to find us. Anything you want to see in term 2, go for it. You have a talk or you have a subject you want to talk about, go for it. I'm very, very happy to leave you this Tuesday lecture or to book another room during the week. And if you want to express something that you have about cyber, feel free. I would be more than happy to give you 10 hours during the day to do that. So yeah, feel free. Thank you very much.